Welcome to Deep Sleep Physics. I hope you're doing well and that you're ready to find some peace tonight. It's a pleasure to be your guide through the mysteries of the dark. Tonight, the journey leads toward the distant lights that have shaped every night sky in human history, toward the slow-burning furnaces suspended in the dark, the stars. Across the vastness of space, stars appear as small and steady points of light, calm, unchanging, almost delicate. Yet each one is an immense sphere of plasma, held together by gravity, balanced by energy produced deep within its core. A star is not solid, not liquid, but a luminous ocean of charged particles, flowing and shifting under its own internal forces. Long before a star begins to shine, it exists as part of a quiet cloud, a nebula composed mostly of hydrogen gas and traces of heavier elements, drifting slowly through space, almost invisible against the blackness. Within these clouds, gravity begins its patient work, drawing particles closer together, increasing density so gradually that the process unfolds across millions of years. As the cloud contracts, temperature rises, pressure builds at the center, and the once cold region becomes a gathering point of immense force. At a certain threshold, hydrogen nuclei begin to move with such intensity that they overcome their natural repulsion, merging together, forming helium, releasing energy in the process. This reaction, known as nuclear fusion, becomes the defining rhythm of a star's life. From that moment, the star enters a state of balance. Gravity pulls inward, fusion pushes outward, and between these opposing forces, equilibrium is established. This balance allows the star to shine steadily for millions, or even billions of years, neither collapsing into itself nor exploding outward, but remaining suspended in quiet stability. The light produced in the core does not reach the surface instantly. It travels slowly through dense layers of plasma, scattering, redirecting, taking thousands of years to emerge from the outer boundary. When it finally escapes, it begins a new journey across space, moving at the constant speed of light, crossing unimaginable distances before reaching planets, moons, or drifting observers in the dark. Every star visible in the night sky represents this same delicate balance, gravity and fusion in quiet cooperation, matter converted into energy, stability sustained through constant adjustment. What appears as a simple point of light is in truth a self-regulating system, sustained by fundamental forces that operate without interruption. And as countless stars continue their silent burning across the galaxy, the darkness between them feels less empty and more like a vast, patient stage upon which light persists, steady, enduring, and calm. Not all stars are alike, though they may appear similar from a distance. Their differences are written in subtle variations of color, temperature, and mass. Each star carries its own internal balance, determined at the moment of its formation, shaped by the amount of material gathered within its gravitational embrace. Some stars are smaller than the Sun, their cores cooler, their light softer and more subdued. These smaller stars consume their hydrogen fuel slowly, extending their lifetimes across spans so vast that they will continue shining long after larger stars have faded. Their stability is quiet and enduring, a gentle persistence that requires no dramatic change. Other stars begin with far greater mass, drawing in more gas during their birth, creating cores of higher pressure and temperature. In these immense interiors, fusion proceeds at a faster rate, producing brilliant blue-white light, luminous and intense, yet shorter-lived. Because greater mass leads to stronger gravity, and stronger gravity demands greater outward energy, these stars burn brightly, but not for as long. Color reveals temperature. A cooler star glows in shades of red or orange, its surface calmer in intensity, while hotter stars emit white or blue light, signaling the rapid motion of particles at their outer layers. This variation in color is not decorative. It is physical, a direct expression of internal energy and surface conditions. Even the Sun, steady and familiar, belongs to a specific category known as a main sequence star, a classification describing stars that are actively fusing hydrogen in their cores. This stage represents the longest portion of a star's life, a prolonged equilibrium where inward gravitational pressure and outward radiation remain balanced. Across the galaxy, billions of stars exist in this stable phase, each following the same underlying principles, yet differing in brightness and scale. Some shine faintly in quiet regions of space. Others illuminate entire stellar neighborhoods, but all are governed by the same laws of thermodynamics and gravity. As starlight travels outward, it carries information about its origin, encoded in subtle patterns within the spectrum of light. Astronomers study these patterns to understand composition, temperature, and motion, revealing the nature of stars without ever approaching them. The light itself becomes a messenger, crossing vast distances in calm persistence. Through this diversity, the night sky becomes a tapestry of variation within order, stars of different sizes, colors, and lifespans, all participating in the same enduring balance. Each one a steady furnace, quietly transforming matter into light, sustaining its presence in the darkness, without haste, without interruption, simply continuing within the patient expanse of space. Over time, even the most stable stars begin to change. Not suddenly, but through gradual shifts unfolding deep within their cores. As hydrogen slowly transforms into helium, the composition at the center evolves, and with it, the delicate balance between gravity and outward pressure begins to adjust. In the earliest stages of a star's life, hydrogen fusion provides a steady source of energy, maintaining equilibrium for millions or billions of years. But fusion is not endless. The supply of hydrogen at the core diminishes gradually, replaced by helium that does not immediately participate in the same reaction. As this transition progresses, the internal structure of the star responds quietly. Gravity, always present, begins to compress the core slightly more, increasing temperature and density once again. Meanwhile, fusion continues in a surrounding shell where hydrogen remains available. This shift marks the beginning of transformation, not a violent event, but a slow reconfiguration of layers, unfolding across immense spans of time. For stars similar in size to the Sun, This evolution leads toward a phase known as the red giant stage. The outer layers expand gently outward, surface temperature decreases, and the star glows in warmer shades of orange and red. Its radius may increase many times over, yet this expansion is gradual, guided by predictable physics rather than sudden eruption. Within the expanded outer envelope, convection currents move energy outward in calm circulation. Deeper layers compress. New fusion processes may begin, allowing helium to transform into heavier elements such as carbon and oxygen. Each reaction produces energy in measured progression, sustaining balance even as structure changes. More massive stars follow a similar pattern, though at accelerated pace. Their cores reach higher temperatures, enabling fusion of increasingly heavier elements in successive layers, forming a structure reminiscent of nested shells, each layer fusing a different element, each stage shorter than the last, yet still governed by equilibrium between gravity and radiation. Throughout these transformations, the star remains bound by the same fundamental forces, adjusting continuously to internal change, never static, yet never chaotic. Its light continues to travel outward, steady and composed, even as deeper processes evolve beyond direct observation. From a distant perspective, the star still appears as a single calm point in the sky, unchanged, constant. Yet within, a quiet evolution unfolds, matter reshaping, energy redistributing, structure adapting in patient sequence, demonstrating that even the most enduring lights in the cosmos are sustained through gradual transformation, guided by gravity, sustained by fusion, and carried forward by time. As the internal transformation continues, the balance within a star grows more delicate, especially for those born with greater mass. Layer by layer, fusion advances toward heavier elements: carbon, oxygen, neon, silicon, each stage unfolding more quickly than the one before, because heavier nuclei release less energy when they merge, requiring ever higher temperatures to sustain the process. In these massive stars, the core becomes structured in quiet layers, each one defined by a different fusion reaction: hydrogen at the outer shell, helium beneath it, and progressively heavier elements toward the center. The arrangement resembles a slow-burning interior architecture, organized not by intention, but by pressure and temperature gradients that naturally define where each reaction can occur. Eventually, iron begins to accumulate at the core, and iron marks a turning point. Unlike lighter elements, iron does not release energy when fused. Instead, it absorbs energy, quietly halting the outward pressure that has balanced gravity for so long. The star does not fail immediately, but the equilibrium grows fragile, the internal support weakening with each passing moment. When the core can no longer resist gravitational compression, collapse begins, not as a gradual drift, but as a rapid inward movement, matter falling toward the center in a fraction of time compared to the star's long life. Temperatures rise sharply, densities increase beyond imagination, and the outer layers respond to the sudden inward motion with equal force outward. This brief imbalance results in a supernova, a luminous release of energy that can outshine entire galaxies for a short period. Yet even here, the event is governed by physics, by conservation of energy and momentum, by pressure waves traveling outward through stellar material, scattering heavy elements into surrounding space. From this release, new elements are distributed into the interstellar medium: gold, uranium, and countless other atoms that could not form under calmer conditions. These materials drift into surrounding nebulae, becoming part of future stars, future planets, future structures not yet formed. The cycle continues, not in chaos, but in renewal. For less massive stars, the ending is gentler. Outer layers expand and drift away gradually, forming a planetary nebula, a softly glowing shell of gas illuminated by the remaining hot core. The central remnant cools slowly into a white dwarf, dense, compact, radiating residual heat over billions of years, fading without violence. Across these varied endings, one constant remains. Stars live through balance and conclude through transformation, each phase guided by gravity and thermodynamics, each transition shaped by internal composition. Even in their final moments, stars remain expressions of physical law, evolving according to principles that never falter, sustaining the quiet rhythm of matter and energy within the vast and patient dark. After the outward brilliance of a supernova has faded, what remains is not emptiness, but transformation. The core that once sustained fusion now exists in a new state, compressed to extraordinary density, balanced once again by different forces, quieter, yet just as precise. For stars of moderate mass, the remnant becomes a white dwarf, a compact sphere roughly the size of a planet, yet containing a mass comparable to that of a star. Matter within a white dwarf no longer behaves in familiar ways. Electrons are pressed so closely together that quantum principles begin to define stability. Not heat from fusion, but the pressure arising from the nature of particles themselves, holding collapse in equilibrium. A white dwarf does not generate new energy. It simply radiates the residual heat stored within it, slowly, steadily, cooling across billions of years. Its glow fades gradually, from white to red, from red to darkness. Yet the process unfolds so slowly that the universe itself has not existed long enough for many to fully cool. In more massive stars, the collapse produces an even denser remnant, a neutron star. Here, protons and electrons merge under immense pressure, forming neutrons packed so tightly that a single teaspoon of such matter would weigh more than a mountain. And yet, even at this extreme density, equilibrium is restored. Gravity pulls inward. Neutron pressure pushes outward. Balance achieved once more. Some neutron stars rotate with remarkable precision, emitting beams of radiation aligned with their magnetic poles. As the star spins, these beams sweep across space in steady intervals, creating the appearance of rhythmic pulses when observed from afar. These pulsars maintain astonishing regularity, their timing so stable that they rival the precision of atomic clocks. Quiet cosmic metronomes, marking the passage of time in distant regions of the galaxy. Even after dramatic endings, stars do not vanish without consequence. Their remnants continue interacting with surrounding space, influencing nearby material, shaping future formations. White dwarfs may draw matter from companion stars. Neutron stars may exist within binary systems, all still governed by gravity's persistent influence. Through every phase, from birth within a nebula to stable fusion to final transformation, stars remain expressions of balance, matter responding to pressure, energy responding to gravity, each stage unfolding according to consistent physical laws. Even in their densest forms, even in their quiet cooling, the rhythm continues, sustained by forces that neither hurry nor falter, maintaining structure within the vast and patient dark. Not all stars travel through their existence alone. Many are born in pairs, or even in larger groups, bound together by shared gravity from the very beginning. Within stellar nurseries, collapsing regions often fragment into multiple cores, each gathering mass, each igniting fusion, yet remaining linked in mutual orbit. Binary star systems are common throughout the galaxy. Two stars circling a shared center of mass, sometimes separated by vast distances, sometimes so close that their outer atmospheres interact. Their motion is not chaotic, but predictable, defined by mass and distance, moving in smooth elliptical paths that repeat in steady cycles. In wider binaries, each star evolves much like a solitary one. Their only connection, the quiet gravitational tether between them. But in closer pairs, interaction becomes more intimate. Material from one star may drift toward its companion, drawn across space in a slow stream, reshaping mass and brightness over time. Even this transfer unfolds according to physical law, guided by gravity and pressure, never abrupt, always continuous. Some binary systems produce gentle fluctuations in brightness as one star passes in front of the other from our perspective, causing periodic dimming that repeats with remarkable precision. Astronomers observe these patterns to measure stellar size, mass, and orbital distance, extracting calm order from distant light curves. Beyond pairs, entire star clusters exist, vast gatherings of hundreds, thousands, or even millions of stars, formed from the same original cloud, moving together through the galaxy. Open clusters are looser, their members gradually dispersing over millions of years, while globular clusters are tightly bound, ancient and spherical, orbiting the galactic center in patient arcs. Within these clusters, stars vary in size and age, yet share common origin, like siblings born from the same nebula. Their collective gravity maintains structure, each star contributing to the overall stability of the group. Even in such crowded regions, motion remains smooth, interactions predictable, balance preserved through shared influence. Across the galaxy, solitary stars, binaries, and clusters all participate in the same underlying rhythm, gravity shaping motion, fusion sustaining light, time guiding evolution. No star exists in complete isolation, each one part of a broader gravitational tapestry woven quietly across interstellar space. And as these countless systems drift together through the Milky Way, their combined light forms the soft, luminous band visible across dark skies. A reminder that every point of brightness belongs to a larger pattern, sustained through connection, held together not by stillness, but by the steady and patient pull of gravity. Within the calm architecture of the cosmos, beyond individual systems and clusters, stars also move within larger galactic patterns. Each one follows an orbit around the center of the Milky Way, guided by gravity that extends far beyond what can be seen. Though the motion is immense in scale, it unfolds with steady precision. Stars circling slowly across hundreds of millions of years, completing a single galactic journey in spans far longer than any human history. Within the spiral arms of the galaxy, stars are not fixed in place. The arms themselves are not solid structures, but regions of slightly higher density, waves moving through the galactic disk. As stars travel through these regions, new formation is encouraged. Gas clouds compress, gravity strengthens, and fresh stars ignite quietly within luminous nebulae. The Sun itself is part of this gentle migration, orbiting within a minor spiral arm, moving at great speed, yet experiencing no sensation of motion, because everything nearby shares the same path. Nearby stars drift alongside, some slightly faster, some slightly slower, creating gradual shifts in relative position over millions of years, forming and reforming constellations that only appear permanent from a short perspective. As stars age, their movement continues unchanged, whether shining brightly, expanding into giants, or cooling into compact remnants. Gravity does not distinguish between youth and age. It simply governs motion with steady impartiality, ensuring that each object maintains its orbit within predictable limits. Occasionally, stars pass relatively close to one another, though close in cosmic terms still represents vast distance. These encounters rarely disturb overall stability because space between stars is immense and gravitational influence weakens with separation. Most stars travel their galactic paths without disruption, maintaining separation that preserves equilibrium. The light from these moving stars spreads outward in all directions, intersecting with other light, crossing vast emptiness without interference. Each beam travels independently, yet together they create the diffuse glow that defines a galaxy. Billions of steady sources contributing to a unified radiance. Through this layered motion, individual life cycles blend into collective structure. Stars born, evolving, concluding, while the galaxy itself persists, shaped by the combined gravity of visible matter and unseen mass. Everything in motion, yet everything balanced. A calm circulation sustained not by force, but by continuity. And within that grand orbit, each star remains a quiet participant, shining with patient endurance, carried through space alongside countless others, part of a vast and ordered system where light endures, motion continues, and gravity maintains the silent architecture of the night. While stars appear steady to the eye, Their surfaces are never entirely still. Beneath the calm glow, currents of plasma rise and fall in slow convection, carrying energy outward from deeper layers, forming patterns that shift gradually across time. These motions are not chaotic, but fluid, shaped by temperature differences and rotation, guided by magnetic fields that thread invisibly through the stellar atmosphere. On the surface of many stars, darker regions may form, areas where magnetic activity temporarily reduces temperature, creating subtle contrast against the surrounding brightness. These regions drift slowly as the star rotates, appearing and fading in quiet cycles. The Sun follows such patterns in measured intervals, its magnetic activity rising and falling across predictable spans, never disturbing its overall equilibrium. Rotation itself varies from star to star. Some spin gently, completing a full turn in many days, while others rotate more rapidly, flattening slightly at their equators due to centrifugal force. Even so, balance is maintained, gravity counteracting outward motion, preserving spherical form within stable limits. In certain cases, stars exhibit gentle pulsations, expanding and contracting in rhythmic patterns, not through instability, but through internal pressure variations that create waves within their outer layers. These variable stars brighten and dim with remarkable regularity, their cycles used by astronomers as reliable markers for measuring cosmic distance, steady oscillations serving as quiet beacons across the galaxy. Magnetic fields extend far beyond the visible surface, interacting with charged particles in stellar winds, streams of plasma that flow outward into surrounding space. These winds carry small amounts of mass away over time, subtle losses that accumulate across millions of years, gradually reshaping the star's evolution, yet never abruptly, always through continuous adjustment. Even in their most active phases, stars remain governed by equilibrium, energy flowing outward at a rate defined by core fusion, pressure balancing gravitational pull, surface activity reflecting deeper processes without overwhelming them. Every flare, every pulse, every magnetic cycle arises from physical principles that restore stability as they unfold. From afar, these complexities merge into simple points of light, calm and constant against the night. The subtle variations, the quiet internal currents, the magnetic patterns and gentle oscillations all blend into steady radiance, reminding us that apparent simplicity often conceals layered motion. And so, even as stars shift, rotate, pulse, and breathe through cycles of activity, their fundamental balance endures, sustained by gravity, powered by fusion, regulated by physics that neither falters nor rushes, continuing quietly within the vast and patient dark. As stars continue their steady burning, they also become architects of matter, shaping the chemical story of the universe. In their cores, lighter elements merge into heavier ones, hydrogen becoming helium, helium forming carbon, carbon giving rise to oxygen and beyond. Each stage unfolds in ordered sequence, guided by temperature and pressure, sustained by fusion that transforms mass into energy. Before the first stars formed, the universe contained mostly hydrogen and helium, simple elements born from the earliest expansion. It was within stellar interiors that complexity began to grow. Carbon, nitrogen, oxygen, the elements essential for planets and life, all forged slowly within luminous cores, released only when stars reach their final stages. When outer layers drift outward, or when massive stars conclude in luminous release, these newly formed elements scatter into surrounding space, mixing gently with interstellar clouds, enriching future generations of stars. The cycle is gradual. Matter redistributed across vast distances, becoming part of new systems not yet assembled. Every planet, every ocean, every living structure traces its material origin to ancient stars. The calcium within bone, the iron within blood, the oxygen carried in every breath, all once existed inside stellar furnaces, fused quietly under gravity's pressure, carried outward by slow cosmic processes. Even dust drifting between stars contains the remnants of previous generations. Microscopic grains composed of silicates and carbon compounds, moving through space with patient inertia, eventually becoming part of nebulae that collapse again, forming new stars surrounded by new planetary systems. The cycle continues, not hurried, not chaotic, but sustained through repetition. Stars, therefore, serve not only as sources of light, but as long-term engines of transformation, converting simple elements into diversity, redistributing matter across galaxies, maintaining a gradual increase in chemical richness over billions of years. Each generation builds gently upon the last, complexity emerging from steady fusion rather than sudden creation. From a distant view, a galaxy may appear as a calm, luminous band. Yet within it, countless stars participate in this quiet alchemy, each one contributing small changes that accumulate over time, shaping the material foundation of everything that follows. Through this enduring process, stars connect past and future, turning simplicity into structure, light into matter, energy into form, all while maintaining their delicate equilibrium, shining steadily, evolving gradually, and sustaining the calm transformation of the cosmos within the vast and patient dark. Across unimaginable distances, starlight travels in silence, carrying with it the history of its origin. The glow that reaches distant worlds is never immediate. It is always a message from the past. Light moves at a constant speed, yet even that speed requires years, centuries, or millennia to cross the spaces between stars. When a star shines in the night sky, it is not seen as it is now, but as it once was. The light arriving at this moment may have left its surface long before modern civilizations began. Some of the faintest visible stars emit light that began its journey before written history, traveling uninterrupted through interstellar space, unaffected by sound, untouched by atmosphere until it meets a planet. This delay is not distortion, but continuity, a natural consequence of distance. Space does not shorten the journey, nor does it slow it arbitrarily. It simply allows light to proceed at its constant pace, crossing the quiet expanse with steady precision. Because of this, observing distant stars becomes an act of looking backward through time. The farther the star, the older the light. Astronomers use this principle to study stellar evolution across different eras, examining populations at various distances to understand how stars formed and changed throughout galactic history. Even entire galaxies appear as they were millions of years ago, their light only now reaching observers after vast travel. Yet within that delay, physical law remains unchanged. Fusion continues in their cores. Gravity continues to shape motion. Equilibrium persists regardless of when the light is finally received. The darkness between stars does not interrupt this journey. Though interstellar space contains faint traces of gas and dust, it is largely empty, allowing photons to pass with minimal interference. Some light may scatter slightly, reddened by fine particles, but most continues in a straight path, preserving information encoded in its spectrum. In this way, starlight becomes both illumination and archive, a quiet record of temperature, composition, and motion, carried across immense spans without haste. Every beam traveling independently, yet contributing to a shared radiance that defines the night sky. And as countless photons continue their patient movement outward, crossing distances too vast to measure easily, they maintain the calm continuity of the cosmos. Light departing, traveling, arriving, never rushing, never pausing, simply moving steadily through the vast and silent dark. Over immense spans of time, the population of stars within a galaxy slowly changes. Not through sudden replacement, but through gradual cycles of birth and conclusion. In certain regions, dense clouds of gas continue to collapse, forming new points of light, while elsewhere, older stars cool quietly into compact remnants. The overall balance remains steady, even as individual lives unfold at different rhythms. Star formation does not occur uniformly across a galaxy. It is more common within spiral arms, where gas clouds are slightly compressed, encouraging gravity to gather material more efficiently. Within these regions, clusters of young stars may shine with bluish light, hotter and more luminous, indicating recent formation. Their brightness contrasts gently with older, redder stars that have persisted for billions of years. As generations pass, the chemical composition of new stars subtly evolves. Each previous cycle of fusion enriches interstellar gas with heavier elements, so that newer stars contain slightly more complexity than their ancestors. This enrichment occurs gradually, accumulating across cosmic time, shaping the properties of planetary systems that may form around them. In older regions of a galaxy, such as globular clusters, most stars are ancient, formed when the universe itself was young. Their light carries signatures of simpler composition, fewer heavy elements, reflecting the conditions of early cosmic history. Yet even these ancient stars remain stable, shining quietly after billions of years, sustained by the same physical principles as younger ones. The balance between star formation and stellar endings maintains a form of galactic equilibrium. Gas consumed in one region is replenished slowly by the release of material elsewhere. Supernova remnants disperse enriched matter. Planetary nebulae expand gently outward, adding their contribution to the interstellar medium. Nothing is wasted. Nothing disappears without re-entering the cycle. Across billions of years, galaxies gradually mature, their rates of new star formation slowing as available gas becomes more diffuse. Yet even in this quieter phase, countless stars continue their steady fusion, maintaining luminous structure without urgency. From a distant perspective, this evolution appears almost imperceptible. The galaxy's shape persists, its spiral arms glowing softly, its central bulge luminous and dense, all while individual stars live their lives within it, each one a participant in a larger pattern sustained by gravity and time. Through this slow generational rhythm, stars define not only the brightness of the cosmos, but its continuity, linking past and future through cycles that unfold gently, never rushed, never chaotic, simply sustained within the calm and patient architecture of the universe. As the cycles of formation and conclusion continue, the galaxy settles into a long-term rhythm, one shaped by availability of gas, by gravitational structure, and by time itself. Regions once rich with dense molecular clouds gradually become quieter, their material either incorporated into stars or dispersed more thinly across interstellar space. Star birth slows, not abruptly, but through steady decline. In these calmer eras, existing stars carry the luminous structure of the galaxy forward. Older red stars glow with softer light, dominating regions where new formation has become rare. Their steady radiance requires less fuel than brighter blue stars, allowing them to endure across immense spans, quietly sustaining the galaxy's glow without dramatic change. Meanwhile, the remnants of earlier generations persist as compact objects, white dwarfs cooling slowly, neutron stars rotating with precise rhythm, black holes resting in gravitational silence. Though no longer fusing elements, they remain part of the gravitational framework, influencing nearby matter with subtle persistence. Interstellar gas does not vanish entirely. It drifts between stars in faint clouds, occasionally gathering again where density increases. Gravity continues its patient work, and under the right conditions, collapse resumes. New stars ignite, adding fresh light to regions that had grown dimmer. The cycle renews itself, guided by equilibrium rather than urgency. Across billions of years, this gradual modulation shapes the character of a galaxy. Younger galaxies shine more brightly with active star formation. Older galaxies radiate with steadier, redder light, reflecting a slower pace of renewal. Yet in every stage, gravity maintains coherence, preventing the structure from dispersing despite constant motion. Even as individual stars move along their galactic orbits, their collective gravity binds the system together, interacting not only with visible matter, but also with unseen mass that extends beyond luminous regions, providing additional stability, preserving shape across immense spans of time. From a distant vantage, the galaxy appears serene, its spiral form luminous against darkness. Yet within, countless processes unfold quietly: fusion sustaining light, gravity guiding motion, matter cycling from one phase to another, never hurried, never chaotic, simply following consistent law. And through this patient balance, stars remain central to cosmic continuity, shaping structure, distributing elements, illuminating vastness, all while maintaining their own delicate equilibrium, shining steadily, evolving gradually, and sustaining the calm architecture of space within the deep and silent dark. Beyond their physical structure and chemical influence, stars also define orientation and perspective. For countless generations, patterns formed by distant lights have guided navigation across oceans and deserts, not because stars were arranged intentionally, but because their immense distances create apparent stillness, fixed reference points against the rotating sky. Constellations emerge from this perspective, familiar shapes traced between bright points. Yet these patterns are temporary, formed by chance alignments from a specific vantage point in space. The stars that compose a constellation may be separated by vast distances, some closer, some far beyond. Their apparent proximity is an illusion shaped by line of sight, not by physical connection. Over millions of years, even these patterns slowly change, as stars continue their independent motion around the galaxy, drifting relative to one another, altering the shapes humans have memorized. The night sky is therefore not static, but evolving gradually, though the change unfolds so slowly that it escapes everyday awareness. Brightness itself varies subtly across the stellar population. Some stars appear prominent due to intrinsic luminosity, others because of relative closeness. Distance and power combine to define visibility. Light that seems faint may originate from an immense star located far away, while a nearby smaller star may shine more brightly in the sky. The interplay between luminosity and distance shapes perception. Certain stars serve as markers for measuring cosmic scale. Their predictable variations in brightness allow astronomers to determine distance with precision. These standard candles extend understanding beyond the immediate galaxy, linking nearby stellar neighborhoods to distant cosmic structures, expanding knowledge through consistent observation of rhythmic light. Even the gentle twinkling seen from Earth arises not from the stars themselves, but from atmospheric currents bending incoming light. The star remains steady, its emission constant, while shifting air above the surface causes slight variations in apparent position. A reminder that perception often reflects local conditions rather than distant instability. Through navigation, measurement, and quiet illumination, stars provide orientation both physically and intellectually, guiding movement, defining scale, offering reference across darkness. Their steady presence has shaped exploration, calendars, and scientific discovery, all while continuing their own gradual evolution beyond notice. And so, as they burn quietly across immense distances, stars remain more than distant furnaces of fusion. They become anchors in space, fixed points within motion, steady lights that persist across time, illuminating not only the galaxy, but perspective itself, within the vast and patient dark. As the perspective widens once more, individual stars begin to feel less isolated and more like parts of a continuous luminous fabric. Each one occupies its own position in space, yet together they form gradients of brightness, soft transitions between dense regions and open darkness, shaping the visible structure of the galaxy. Within spiral arms, younger stars glow with cooler blue-white tones, clustered gently where gas remains abundant. Between these arms, older stars drift in quieter orbits, their warmer red light spreading more evenly through the galactic disk. The variation is gradual, not sharply divided, a slow blending of age, temperature, and density. At the central regions of a galaxy, stellar populations grow denser, stars orbiting closer together, their combined light forming a steady glow that appears almost continuous. Yet even here, motion remains orderly, governed by gravitational balance. Each star tracing its own path within the shared gravitational field. Beyond the visible disk, a more diffuse halo surrounds the galaxy. Ancient stars moving in elongated orbits, remnants of earlier epochs, their paths shaped by the long history of gravitational interaction. These outer stars are sparse and faint, but they remain bound, participants in the same grand orbit that defines the whole structure. Across billions of years, the positions of stars shift slowly. Spiral patterns evolve. Density waves migrate through the disk. Yet the overall architecture persists because gravity provides continuity, balancing motion against dispersal, ensuring that despite constant change, coherence remains. The galaxy itself rotates in measured rhythm, carrying every star along its path, while each star simultaneously rotates and evolves according to its own internal clock. Movement layered within movement, scale nested within scale, yet never collapsing into disorder, because each level operates within stable limits. From afar, a galaxy appears serene, a quiet spiral suspended in darkness. Its countless stars blend into a unified radiance, obscuring the individual processes within. The complexity becomes simplicity at distance, a reminder that large-scale calm can emerge from countless small equilibria maintained across time. And within that vast structure, each star continues its steady fusion, emitting light into surrounding space, contributing to the shared glow, sustained by gravity, powered by nuclear balance, evolving gradually, without haste, forming the luminous architecture of the cosmos within the deep and patient dark. As countless stars continue their steady fusion, the broader pattern of the universe begins to feel more unified. Light emerging from distant regions overlaps gently, forming subtle gradients across space. No single star dominating the whole, yet each contributing to a collective brightness that defines the night. Over immense spans of time, some stars drift farther from their birthplaces, clusters gradually dispersing, gravitational ties loosening slowly, allowing members to join the wider galactic field. This dispersal is not disorder, but expansion within balance, each star maintaining orbit even as local groupings evolve. Within planetary systems that form around certain stars, the steady output of energy provides conditions for structure, for atmosphere, for surface change. The stability of stellar radiation allows matter nearby to organize, to cool, to settle, demonstrating how calm fusion at the center can influence distant environments without interruption. Even as stars age, their outward light remains consistent for vast periods, providing predictability across cosmic scales. Variations occur gradually, brightness shifting over millions of years rather than moments, ensuring that surrounding systems adapt without sudden disruption. In regions where star formation has slowed, older stars dominate, their softer red glow blending into a gentle background luminosity. The galaxy matures through these transitions, not losing structure, but shifting emphasis from rapid creation to quiet endurance. Beyond the visible disk, intergalactic space extends in near darkness. Yet even there, isolated stars and faint galaxies continue their steady emission. Points of light suspended within distances so great that silence feels complete. Gravity still operates. Light still travels. Equilibrium still holds. Across all scales, from individual stellar cores to galactic spirals, the same principle persists. Inward pull balanced by outward energy. Motion sustained by consistency. Transformation unfolding without haste. The complexity of stellar life cycles resolves into simple continuity: fusion, gravity, time. And as awareness settles on that continuity, the countless individual processes begin to merge into a single impression, not of movement, but of steady presence. Light existing calmly within darkness, enduring across ages, maintaining structure without strain, within the vast and patient cosmos. Gradually, the distinctions between individual stars begin to soften. The immense furnaces hidden within their cores, the layered shells of fusion, the magnetic fields threading through luminous plasma, all settle into a broader sense of quiet continuity. What once felt like separate stories of birth and transformation now merges into a single, steady presence of light sustained across distance. The galaxy continues its slow rotation, carrying billions of stars along vast orbital paths that require hundreds of millions of years to complete. Yet within that immense motion, there is no sensation of speed, only balance. Each star moves because gravity guides it, and gravity guides it because mass curves space in patient consistency. Nothing accelerates without reason. Nothing drifts without boundary. Equilibrium is restored again and again. Light departs from stellar surfaces in every direction, photons leaving without awareness, traveling outward at constant speed, crossing regions so empty that silence feels complete. Some beams move for years, others for millennia, some for spans so great that entire civilizations rise and fall before their arrival. Yet the journey remains unchanged, steady, uninterrupted, defined only by distance and time. The darkness between stars no longer appears vacant, but expansive, a quiet medium through which energy flows. Within that vastness, gravity extends invisibly, linking distant objects in subtle relationship, maintaining structure across scales too large to perceive directly. The architecture of the cosmos depends not on closeness, but on connection sustained across emptiness. Even as individual stars evolve, expanding gently into giants, cooling into compact remnants, or dispersing material into surrounding clouds, the underlying laws remain constant. Pressure responds to compression. Temperature responds to density. Matter rearranges according to thermodynamic balance. No event stands outside these principles. Every transformation arises from them. Across billions of years, new stars ignite where older ones have faded, enriched gas gathering once more under gravity's patient pull. Fusion begins again in fresh cores, repeating patterns established since the earliest epochs of the universe. The cycle does not require intervention. It unfolds because conditions allow it, because balance permits it, because energy and matter follow predictable paths. From a widening perspective, the countless variations of stellar life resolve into rhythm. Inward force met by outward pressure, collapse followed by stabilization, brightness sustained through equilibrium. Even the most dramatic transitions return to calm once balance is restored. Nothing remains in chaos. Every disturbance settles into structure. The galaxy itself drifts through larger cosmic currents, orbiting within a cluster of galaxies, carried by gravitational influence extending beyond visible boundaries. Yet even this greater motion remains smooth, coordinated, unfolding across spans so vast they resemble stillness. Layer upon layer of movement, each nested within another, each governed by the same quiet laws. And as awareness softens further, the individual processes recede, leaving only the impression of steady illumination. Light enduring across darkness, structure persisting through time, continuity maintained without strain. The universe does not rush its transformations. It allows them to unfold gradually, restoring balance whenever imbalance appears. In that calm persistence, the night sky becomes something more than distant points of light. It becomes a reminder of stability within motion, of order emerging from physical law, of endurance sustained by equilibrium. Every star shining because gravity and fusion remain in agreement. Every galaxy glowing because countless balances hold. And as the light fades, the silence becomes absolute. Tonight, you have drifted through the mysteries, absorbed the peace, and understood the ancient rhythm of the cosmos. Remember that the universe is always holding you, a constant, silent anchor. Rest now, deeply. Sleep well, and I look forward to guiding you again through the physics of the dark. Good night.